Hi, welcome to Lesson 3. We are still doing a unit on forces in motion, so it's still important that we understand what those things are, but we're also going to be talking here about how to model motion, or how we show motion, how we can graph motion, and what we're going to be using today to do that is going to be called a motion map. Okay, so we're going to be making something called a motion map today. All right, so first thing you're going to want to know is there are certain parts of a motion map that you're going to want to know about. So I'm going to show them to you. Let's get started here. We're going to make an X. First I'm going to mess up. There we go. We're going to make an X. Okay, so this X right here, this is actually what we're going to call our reference point. So let me use a color. We'll turn this off. So this is going to be what we label as the reference point. Or you might notice that I'm going to call it the RP, or you could call it the POR, point of reference. Either way is fine, doesn't matter. Okay, so that X just indicates some point of reference. We're just saying that the motion is going to happen relative to that point. That's all it is. Then you're going to want one of these lines right here. I really should make that a different color and not make it green, so let's make it black. Sorry about that. So we are going to call this line right here, this is actually going to be the axis. Okay, just like if you have a normal XY graph in math class, this is your axis. And the direction that the arrow is pointing is telling you which way is the positive direction. Okay, so those are the big things that you're going to need to care about. There are a couple of other things that we are going to look at here. And those things are circles. Okay, like this. And arrows, like this. Okay, so circles and arrows are going to be a big part of what we're talking about when we're doing motion maps. The circle is going to represent time. And the arrow here is going to represent the velocity, or in this case, yeah, it's always the velocity, because velocity is the same thing as speed with a direction. And these arrows are always, that's bad, sorry. These arrows are always going to have a direction, so the velocity is always going to be telling you which way it's going. So in this case, it's going in the positive direction, or to the right of your screen. Okay, so that's what that's all going to mean. I would highly recommend that you write these things down. When we go on to the next slide, this is going to make a little bit more sense to you. But as we go, I would write all this down. I would create each motion map. I would label the reference point each time. You're going to kind of see how I'm doing it, get into the habit of doing it the same way as me. All right, so onward, here we go. All right, so we're going to first draw the motion map of an object that is staying still. So in order to do that, we're going to start by putting our X in here. That's our reference point, right? So I'm just going to call that my RP because it takes up less space. And then I'm going to throw in a big axis. Okay, so that I know which way the positive direction is. I like to label mine with positive just to remind me. Okay, so we're going to be drawing something that's staying still. So in order to do that, we're going to want to get a circle out, and we're just going to put a circle on there, right? And you could just draw this. In fact, I think I'm just going to draw them because that's what you guys would be doing. So let me do that as we go. So let's say we start away from the reference point somewhere in the positive direction. So let's say this is maybe 5 meters away or something like this, right? We're going to put a dot. That circle right there is the beginning of our first time, which we're going to always use seconds. So that's the beginning of second number 1. So I consider this to be time equals 0. Then, as time goes on, every additional circle is an additional second. And you can stack the circles vertically like this, because the motion only happens from left to right. So this means that the object is staying in the exact same location, and it's marking time for 1, 2, 3, 4 seconds. You'll see there's 5 circles because the time between each circle is actually the full second. Okay, so if I tell you it's waiting for 3 seconds, it will have 4 circles because the first circle is the beginning of time. That's time 0. Okay, so that's the convention we're going to use. So this object is considered to be staying still, right? Because we're only measuring motion across from left to right or right to left. So this object is staying in the exact same position, and it's just marking time. Okay, so that's what staying still looks like. I would highly recommend that you write this one down. Okay, The next object is going to be traveling with what's called a constant velocity. It's going to be doing that fast. So it's going to have a constant and a fast velocity. So let me draw the axis, throw in my reference point here. Oops, sorry that those arrows have heads. There we go. And then we'll mark this as our reference point. Okay. So let's say this object is going to be going constant fast positive velocity. And let's say that it starts from the reference point. Okay, so that means we're going to start here. So I'm going to put my object here. Sometimes I fill in my circles. So we're going to start here. That's time 0. Okay, and it's fast, right? So if it's constant and fast, the arrows should be the same size, and they should be pretty big. That arrow is fairly big. So after 1 second, we've gone this distance. This is the same size arrow. After 2 seconds, so 0, 1, 2, we've gone this distance. So we're doing that with a constant and a fast velocity. So pretty much right at the end of the arrow, I'm going to put the next circle to indicate that time's going by. So your arrow is pretty much always in a circle. So this total time is 0 to 1 to 2 to 3. So if we were to describe this one with our words, we would say the object starts from the reference point. It has a constant fast velocity in the positive direction for 3 seconds. Boom. Okay? So let's say constant and a fast velocity. I wanted you to see that one. All right, on to the next. Constant and slow. So same exact thing as we have just done, but now we're moving with a slow velocity. We're still going to go in the positive direction just because I am nervous about doing it in a negative direction to start. So we'll call it positive. In this case, we'll start away from the reference point, just so you can see what that looks like. So we're going to start somewhere out here in the positive direction. Okay. Now we're going constant, slow, and positive, so we're still going to the right, but we're going slow, right? So these arrows are the same size to represent constant velocity. Hopefully they're the same size. If I'm a little bit off, I'm really sorry. I'm trying my best. Okay, so this is essentially what's happening. We're making a chain of arrows that are the same size, and we're going from there. So if this is second 0, 1, 2, 3, 4, 5, 6. So we would say we start away from the reference point. We travel with a constant slow velocity in the positive direction for 6 seconds. Okay, so that's that one. I want to now show you what it looks like when you're traveling in the negative direction. So, I just hand drew that. I'm sorry. I have better tools. I can be a big boy. There we go. That looks very nice and official. Let's put our reference point here. So constant negative velocity. So let's say we start. So we'll start really far away from the reference point this time. And this is still the positive direction, remember. So let's say we start way over here. Okay. Now what we're going to do is we're going to head back in the direction of the reference point. That is the negative direction. And you'll notice I'm trying to do this with a constant velocity as well, right? So this is time 0, 1, 2, 3. So we'll say that we're traveling, starting away from the reference point, traveling with a constant negative velocity for 3 seconds. Okay, so that's how you would do a problem like this. Not ready for that one yet. Let's put a new problem in there. Okay, so I want to show you what happens now when you turn around. Okay. So we're almost there. We're almost done. What we're going to do now is we're going to turn around. There you go. Okay. So let's say that we start, at the reference point. Okay. So we started here. And I could have done it down here. It makes no difference. Top, bottom, doesn't matter. The axis only cares about the x and only cares about the left and the right. It doesn't care about the up and the down. So these two places to start, they are equal. Okay, you could start at either one of them. It makes no difference. In fact, why don't we start on the bottom just because I can? So I'll start down here. This is going to be time equals 0. Okay, if I started at the reference point, I'm going to start with a positive, constant, fast velocity for 3 seconds, then something else will happen. So let's do constant, positive, and fast for 3 seconds. So you can sketch that in as I go. Sorry, I missed a little bit. Same size arrows for 3 seconds. Time 0, time 1, time 2, time 3. Then let's have it wait for 2 seconds. Okay? This is the beginning of the wait period, so that's 0, 1 second, 2 seconds. Okay? You'll notice that essentially anytime I give you a time like this, there's one additional dot. Okay? So that's where I've waited for 2 seconds. Now I'm going to turn around, go negative for 3 seconds, constant, slower. Okay? So at the beginning of this time, I'm going to take off. I'm going to go slower, so I'm making a smaller arrow. So it's 1 second. That's 2 seconds. That's 3 seconds. Boom, we did it. That's the whole story, right? That's how you would do these things with constant velocity. That's pretty much everything that I could tell you about with the constant velocity. Now, what happens if your velocity is not constant? Not constant. What happens now, right? So let's throw our axis in here. I'm just going to show you one of these because you'll start to figure it out. Okay, so if your velocity is not constant, let's say we start at the reference point just because, oh my gosh, sorry, just because we can, right? Let's say we are speeding up. Speeding up in the positive direction. Okay, so we'll start with a small arrow, and then every second that goes by, our arrow will get even bigger. See how that works? That would be speeding up. And then down here I'll show you slowing down. So slowing down, you'd start fast, and your arrows are going to get smaller. Isn't that something? Okay, that's the whole story. Thanks for watching.